Hello and welcome to my talk about McAfee application control. My name is René Freingruber and I'm going to tell you something about application whitelisting in the next 50 minutes. So let's have a look at the plan for today. First of all, I will introduce my company, DeepSec Consult. Don't worry, it's just one slide. And then we start with the real topic, application whitelisting. So what is application whitelisting, where is application whitelisting used, and what problems are there? Then I will introduce McAfee application control, which is one software which can be used for application whitelisting. It's also called Solid Core or Mac, so Mac is just a short form of McAfee application control. Next, I come to the different bypass techniques. There I will talk about how you can bypass the protections and also some vulnerabilities, as well as some vulnerabilities in the kernel land. At the end, I show you some demonstration videos so that you see everything is really working and that's not just theoretical. At the end, I give you a short conclusion. So this is mainly about the vendor response, what says the vendor, what is currently fixed, what is not fixed, and of course how you can fix it yourself. DeepSec Consult was founded in 2002 in Wiener Neustadt. We have our headquarters in Vienna. With a security team of over 60 security experts, we make many technical audits, so really persons who are doing technical security penetration testing. And I think one interesting note for you is that we are currently hiring, so if you're interested, just come to me after the talk or go to our booth outside. And yeah, we have offices all around the world. Application whitelisting. So the idea of application whitelisting is if you have servers, you just have a few applications installed on them. So like web server, database server, maybe your antivirus product, and so on. And these applications change very rarely. That means what you can do is, you can install all your applications and then install application whitelisting. Application whitelisting then creates a database, a whitelist of all installed applications. And after that, if you then execute an application, the application whitelisting always checks, is this application already in the database? So is it whitelisted? If yes, it was already there, that means you can execute it. If it's not in the database, it means it was not there, that means execution is prevented. So for example, if you go to a website, you download a virus or a malware or something like that, the malware cannot execute itself because it's not in the whitelist. So this is the main idea behind it. This is mainly used in critical infrastructure systems like SCADA environments, like power plants or medicine computer systems, or something like that. Or some important company systems or administrative workstations and so on. It's also used at kiosk systems. That means, for example, computer systems for students where you can just go there and you don't want that one student infects the other student with something. So you can there prevent the execution of unwanted applications. There are many solutions for it. McAfee is just one of them. For example, Microsoft AppLock is also very commonly used. And I received a license for McAfee application control during a custom project, so that's why I'm focusing on this software here. So I only received the Windows license. There's also a Linux version of it, but I didn't have a look at the Linux version. So we're just covering Windows stuff here. I made all my tests with version 6.1.3, which was the current version when I was doing the older tests. And I have done mainly the tests on the client systems like XP, Windows 7, Windows 8.1. But I've also done the tests with, so I just verified that all techniques also work on Windows 2003, Windows 2012, and so on. The reason why I've chosen XP is that XP is very commonly used in SCADA environments, but of course you should not use XP anymore because it's just not supported. So just don't use XP anymore. And on 2008 I was not able to make it working because every time I was installing the application whitelisting, the operating system doesn't work anymore. So don't really know why this was the case. But basically everything works on server versions too, and on 64-bit systems too. If you want to work with McAfee application control, you basically work with a console application. So you don't have a graphical user interface, you just have here the S-admin tool, and then you provide the command which you want to execute. So for example, you say disable or enable or passwd to set a password, or you can call solidify. Solidify is the main command which is used to enable the application whitelisting. So you give solidify, and then it iterates over all files which are on your system, and then it creates a database. So in this example, it says here, we have iterated over these files, and we have now 2,500 files in your whitelist, in your database. Next step is that you enable the protections, and then you have to reboot the system, and then the protection works. So, for example, if you download an application and try to execute it, it would just say permission is denied. Or if you try to execute a script, like a bat file, it would just say access is denied. There are some other features, for example, write protection, which means it prevents you from overwriting the applications. For example, if you have one whitelisted application, you cannot just overwrite it with your own application, because then you would easily can bypass the protections. There's also a read protection. For example, you cannot read password files, configuration files, the whitelist itself, the database file, and so on. But you can also add read protections for all other files if you like. And we have some memory corruption protections, I will come to them a little bit later. Another important concept are the updaters. So the main problem of application whitelisting is how you deal with updates. So for example, if you have application whitelisting installed and you're using one application, and this application tries to update itself. So it replaces its own libraries, and these libraries, because of write protection, can't be replaced. Or you cannot add a library because the library is also protected, so you cannot load the new library. And what McAfee application control is doing is they specify here a list of special processes, and these processes just completely bypass all protections. So these processes can overwrite all files, and these processes can start applications which are not in the whitelist, so that your updates are working. You see here, it's mainly McAfee applications, but some like Apache is here, or you see here, it's the Java update process, and yeah, some Mozilla stuff and so on, but mainly McAfee products, so that their own antivirus products and so on work. In addition, we have some memory corruption protections, but because the problem is, if you have a memory corruption vulnerability, you can inject code into one of the whitelisted applications, which means you can bypass application whitelisting. So this is the reason why they use memory protections. You see here some sites from them, from their site, like this is so typical sites, like you cannot exploit buffer overflows with their protections, or they protect against zero-day attacks and APT attacks, or here vulnerabilities cannot be exploited through a buffer overflow anymore. I have here diagrams. These are the main components of McAfee application control and how they work together. So basically, we have here a user sitting in front of the system who types some commands and interacts with the sadmin console application. So you just say there sadmin enable or sadmin solidify and so on. Then we have a service. This service runs with system privileges, and this command line tool interacts with inter-process communication, so we are named pipes with the service, and gives the commands to the service. The service is then responsible to create the database, so for example to iterate over all files and create the whitelist. And then we have a kernel driver component, which is sitting here as a kernel driver, and who is responsible to implement all the protections. So for example, every time an application gets started, the kernel driver checks, is this application in the whitelist or not? And the service is speaking via input-output control codes with the kernel driver, like with every kernel driver. We now come to the bypasses. So if you have the problem that we cannot execute our own application, the idea is simple, so we just start to execute whitelisted applications, applications which we can execute. And it means we have to find an application which is there on all systems, because we want that our bypasses work on all systems. So we have mainly three possibilities. So first of all, we'll use something which is installed by Microsoft Windows. But then we have the problem that on Windows XP there are other binaries as on Windows 7 and so on. So we get there some troubles. Then we can use applications installed by McAfee application control itself, which would be very good if we find there something useful. Or we can use some common third-party tools like Office, Adobe Reader, Flash Player and so on, which is very commonly used. But this would be I would choose one of the first two approaches, because the last one does not work on all systems. But basically I found in all three categories some stuff. So the first thing which comes into your mind is PowerShell, because it's available since Windows Vista, and it's solidified per default. So I know if I have a modern operating system, because nobody should use XP anymore, I have PowerShell there, and I can use it. And I can use PowerShell to invoke shellcode, which means I can execute any instruction which I like, and that means I have bypassed application whitelisting at this point. So yeah, you see here, so you cannot pass a PowerShell script there because executing PowerShell scripts is not enabled on all systems by default. But what you can do is, you have here PowerShell, and you can give it an encoded command, and you can pass the complete script here as argument, and this works on all systems. So in this case, it's just base64 encoded, and the command in this case is just to start the calculator. But of course, we can start any other script which we like. And the question is, which script do we want to start? We can just have a look at PowerSploit, which is a very powerful collection of PowerSploit scripts. PowerShell scripts. You can find it on GitHub, and there are many different examples. For example, here we can inject PE files, which means we can load any executable now into memory and start any executable. Or we can invoke shellcode, or start keylogging, mimicuts to dump cleartext passwords, port scanning, and so on. Many, many more. We can even write the complete malware inside PowerShell. So just a quick note, this is the script which I'm using. It's from the social engineering toolkit. This just injects my shellcode into the process space and just starts execution of it. So recap, if we somehow manage to start PowerShell, we can completely bypass application whitelisting because we can start any executable, we can start shellcode, and so on. But the main question now is, how do we start PowerShell? Because we cannot just send a BAT file to the victim, because BAT files are also whitelisted. So our BAT file would not execute. So my idea here was to divide the overall task of getting code execution into two small steps. So the first step is to get something like basic code execution, which means you can execute some scripts like JavaScript or Visual Basic script or something like that. And with the script, I can then start other applications on the system, like PowerShell. And these systems, this is step 2, are used to get full code execution. So I'm then starting applications which can be used to execute shellcode. So let's talk first about basic code execution. So here we have some simple ideas. If you just want to start PowerShell, for example, if you're just sitting in front of the system, we can just type it in there. So it's really a basic attack, but it just works on kiosk systems like workstations for students or something like that. But we can use this idea with USB sticks, malicious USB sticks. It's called Rubber Ducky. You can order this on the internet. It's just a USB stick which interacts as a keyboard. So if you plug it into your computer, it doesn't say it's a USB stick. It says I'm a keyboard, and I'm now typing what I've configured before. So in this example, it would just start notepad.exe and write there some hello world stuff. But you can also say start PowerShell with my malicious payload. So you can just make a social engineering attack, give you this USB stick, and if you plug it into your computer, you're just infected. And application whitelisting does not protect you from that. And the most common attack scenario is if you just send the victim a file, and the victim just starts or opens the file and he's infected. However, this does not work with application whitelisting because we mainly use exe files, BAT files, or something like that, and these all are just whitelisted. However, I found out that they have forgotten some of them. So first one is HDR files, which are HTML application files. So you see here, this is a normal HTML file, but you can use Visual Basic script in here. And with Visual Basic script, you can just run anything that you like. Like in this example, I'm just starting the calculator, but you can also start PowerShell or something like that. So if someone clicks at this HDR file, he's just infected as well. You will see it a little bit later in the demonstration videos. GS files is basically the same. You can do the same. You can start any application. Or you can just use file shortcuts. So I can just create a shortcut pointing to PowerShell. And then in the arguments, I just pass my malicious payload. So it would look like something like this. And if you click it, PowerShell just get executed. In this case, I'm just spawning calculator, but of course I can also spawn a reverse shell or some other stuff. What my idea was to have a look at the most common attack vectors and then have a look if they're working against application whitelisting enabled systems. So the first part was only social engineering attacks. So now come to other attacks, like if I'm attacking a web application, I find there are some vulnerabilities and I try to attack the system, but the system is protected via application whitelisting. And in all these cases, it's possible to execute some commands. So for example, with these vulnerabilities here, for example, if I have SQL injection, which is badly configured, I can use into_art file to write the web shell to the web server, and then on the web server, with the web shell, I can execute any command which I like. That means I can execute PowerShell again, or something like that. So that means in the case of web application vulnerabilities, it's also possible to bypass application whitelisting. Another attack scenario are pass-the-hash attacks. When I go to a customer for internal audit, I typically have two laptops with me. So one laptop with an automated security scanner who just runs thousands and thousands of scans against the complete network. And my own laptop, which I use this laptop to make web application audits and stuff like that, which you cannot automate. So at the end of the day, in 99%, I have a critical vulnerability either with the automated security scanner or with my web security audit. So that means in nearly all cases I have at least access to one server system. So for example, if you have a very old system which is not updated, or if you have, don't know, JBoss with default credentials or something like that. If you then have access to one of the systems, you can dump the password hashes. And the problem is that Microsoft has a design flaw in their protocols, which allows me to authenticate against systems if I just know the password hash. I don't have to know the clear text password. And this attack is called pass-the-hash attack. So if the administrators configure the same local administrator password on all server systems, I can just access one, can compromise one system, then dump the password hash, and use this password hash to authenticate against the next systems. And I'm typically doing this until I find the clear text password of an domain administrator in memory, and then I've compromised the domain controller and everything is over. This pass-the-hash attack you're using typically the Metasploit module PSExec for it. So it would look like something like this. So if you attack here the system with a P139 and get there a shell, you make hash dump and now you have the hashes here. And then you can just use PSExec, set here the hash again and attack another system. So in this case, with the IP address 133. And then you just get a shell there. However, if you protect your system with application whitelisting, this attack is not working. Sorry. Yeah. And to find out the reason why this is not working, you have to just have a look at the source code. So in this case, the source code is this one here. It looks a little bit complicated, but on the next slide I have it more readable. So if you want to execute the command who am I over PSExec, you would end executing this whole command here. So basically you're just starting cmd_exec with a command. The command is then here echo, so you're writing this stuff here into the file temp.bat. Then you say I want to execute another command. Command just starts cmd_exec again, which starts cmd_exec, which just starts the temp file here, the temp.bat file. This is, I think, just to bypass all the heuristics of antivirus products. You basically end up executing this file here, temp.bat, and in this file you just find who am I, and the output is piped to random name. The problem in this case is that this temp.bat is not whitelisted, which means execution is just prevented again. And to modify it, it's really, really simple. You just have to modify the command here to directly execute your commands. You don't have to write a bat file. So application whitelisting does not protect you against this stuff. And this is a good example because in really old cases, application whitelisting protects you from the basic attack. But if you just use 5 minutes of your time, you find a bypass and it's working again. So it really just protects you against the basic attacks. But if someone has advanced knowledge, he can really easily bypass all the stuff. And now come to full code execution. Until now, we just discussed PowerShell. So someone can say, okay, I just removed PowerShell from my whitelist, so you cannot execute it anymore. I'm now protected. But that is not true, because there are many, many other applications which are installed which you can also use to get code execution. So here are just some of them. For example, run DLL32, because it can be used to load a library and call a function of it, so you can build your buffer overflow, for example, yourself. Or if you have Python or Perl installed, it's just basically the same as PowerShell. You can just pass the argument, the payload in the argument and execute shellcode. Or debuggers, because debuggers can be used to inject code into the process space of whitelisted applications. Here are some other common attack vectors like Java applets. A typical Java applet, a malicious Java applet, looks like this. So in the case of a social engineering attack, I would somehow force a victim to go to my website. For example, I write phishing mails and tell them, go to this website, there you can calculate your Christmas bonus or something like that. This works really good. And what I'm doing then is, typically you have in the resources your executable, then you just dump the executable out to a temporary file, and then you just start it. And here again we have the problem that this malware here is not whitelisted, which means execution is prevented. So what you can do is, of course, you can just invoke PowerShell again, but in this case we wanted to do it without PowerShell. So what you can do is you can directly inject your shellcode into the process, into the Java process. Don't have really enough time to talk about all details here today, but if you want to know more about it, just go to YouTube, then you can find this talk, or on GitHub you find the code for it. So you can really run shellcode in the process space of Java. This is basically the same for Office macros, so if I just send you a PowerPoint file or Excel file or something like that, and you enable macros, I can start applications, which means I can start PowerShell, or just inject my own code into the PowerShell, into the Office process. You can do this with the script here. It's called shellcode to Visual Basic script. You can find it here. And if you want to make it work against 64-bit systems, you just have to make some minor modifications. The last technique is we are exploiting memory corruptions. So for example, if you go to my website and I have a zero-day exploit for your browser, I can just inject code into your browser. The browser is whitelisted, which means I can execute code on your system. But we can also do it in local applications. For example, if I'm able to execute some scripts like JavaScript and code some local applications, but PowerShell is not there on your system, I can just exploit a local application. And the question is, which local application should I exploit? So I mainly have two possibilities for this. I can use one application from the operating system, but there I have some problems because the operating system developers know what they're doing, so at least the most time. So they have many different protections like address-based anonymization, data execution prevention, safe exception handling, control flow guards, stack cookies, and so on, and they have enabled all for them. So it's very hard to exploit such an application. And of course, if on Windows XP I have other applications as on Windows 7, that means I have to write one exploit for XP, one for Windows 7, one for the English version, one for the German version, and so on, which is quite hard. So what my idea was to search for applications installed by McAfee Application Control, because I know that they are stored on old systems, if McAfee Application Control is there, and maybe they have just forgotten some protections. I then found this one here. This is a zip file installed in the program files folder of McAfee Application Control. It's from 1999, which is very good for me because at this time there were no security protections, so I know that there are no security protections. And then I started to search for it on Google. Then I found this one here from 2004. It says execute code overflow, which sounds quite good. This one here is red, which is also quite good. And unfortunately, I don't find any public information for this, so I didn't really know how to exploit it, but I just know there is a vulnerability in there. So then I just grabbed the source code and started searching for the vulnerability. So maybe you can just have a quick look at it. Just a quick note, we are not FarmS, so this is not here. So the vulnerability is something somewhere like here. Just give you a short time to have a look at it. So basically, it's quite a simple vulnerability. We have here string cut, which means you're concatenating strings. Error buff has a fixed size, and we're taking here directly the arguments. So arguments are user controlled, attacker controlled. So that means this is fixed size, and we can just write as much as we like into a fixed size buffer. It's a basic buffer overflow. Really simple. Just as a quick side note, at the time when I was doing this research, I had access to a very expensive source code analysis tool, and I used it to find here vulnerabilities. It gave me about 150 vulnerabilities, so it says 150 buffer overflows or something like that, but all of them were just not exploitable because he was allocating exactly the space before writing to it. And this here was the only vulnerability which was exploitable, and exactly this vulnerability was not found. And I really don't know why, because this is a really, really simple vulnerability in this case. So if you just pass many, many A's, you just see the application just crashes. You can load it up in a debugger, and you just say here, you're overwriting the register. Okay. Sorry. You can overwrite here the register with 6.1, which is exactly the A's. That means you can overwrite here the target location. And of course, you can also use some tools which just say this is exploitable. Basically, we have here a tool from 1999 with no security features. The buffer overflow is in a BSS section, and you can control the arguments to F, flush, and free, and you can use this to exploit it to run your own shellcode in it. And this is whitelisted by default because it's installed on all systems by McAfee application control. But there are some memory corruption protections which should prevent you from exploiting this vulnerability. So let's have a look at it. So again, here's the site. So they just say you cannot exploit buffer overflows anymore. On Windows XP, you have here the MP for memory protection, CASP and Wasser, but Wasser is disabled. On Windows 7, everything is enabled, but you get here also forced relocations. And on Windows 8.1, just everything disappeared, so there are no memory protections anymore on Windows 8.1. We will see a little bit later why this is the case. So what my idea was to just start my own exploits, which I wrote some time ago, and just verify why they are not working, and then just work until it works again. And so I was using here Firefox exploit. You see here, this is Windows 7, all protections are enabled. In this case, I have stored the HTML file locally, but you can also use it via web server, and then you just force a victim to go to your website. In this case, I have here a Go button. This is just for me for debugging, but I can also launch it automatically. And you just see here, the shellcode gets executed, and the shellcode just spawns the calculator. But of course, I can also start a reverse shell or something like this. But you see here, this attack just worked without any modification on the first attempt. So what I thought then is, okay, the Firefox vulnerability is an integer overflow, and they just say they protect against from buffer overflows. So the next step was to use a buffer overflow, in this case VLC player, but I think I just skipped the demo because of timing reasons. It just worked again the same way. So I then thought, what should I test next? And then ended up using the debugger and check what McAfee application control is doing, because I just was just searching for the memory protections because I can't find them. So without McAfee application control, your application looks like this. And with McAfee application control, they're just injecting here an additional library, which is called SC inject. And then you receive many, many access violations in the debugger when McAfee application control is installed, and always around this address here. So my next step was to find out what is stored at this address here. So without McAfee application control, you can find the kernel32 header from the library here. This is a library from the operating system, and you have here the PE header of it, which is readable. And with McAfee application control, the same header is stored there, but now it's not readable anymore. This means every time an instruction tries to read from this location, an access violation is triggered, and that means code from this SC inject library here can kick in and add additional checks. So basically, shellcode always has to, or nearly always has to read this P header, and what they are doing is they make a breakpoint here so that their code can check if the triggering instruction is from shellcode or not. And what they do is they just say, is this triggering instruction loaded in an executable memory? Then it's allowed. And if it's not executable, they say it's just shellcode. But this is just basically the same as data execution prevention, because on modern operating systems, we have data execution prevention supported by the hardware. So data execution prevention from the operating system is much harder to bypass than this CASP. And that means when I write an exploit, my exploit is written so to work against modern operating systems. That means I have to bypass data execution prevention. And that means at the same time I'm also bypassing their protections here too. There are just very, very few systems which don't have the hardware for data execution prevention, and just in these cases you should use this one here because this is then the software version of data execution prevention. Of course, you can also bypass this one here if you don't want to bypass data execution prevention, but this is not so interesting, so just skip it. But something other very interesting is that they inject into all protected processes here a memory. So SC inject allocates memory after anti-delay, which is readable, writable, and executable. And if you allocate something which is writable and executable, this is very bad because this is exactly what you should not do, because this completely bypasses data execution prevention. So for example, if you have a look, you would not find here anything which is executable and writable. Just the stuff which is allocated by McAfee application control. This is very bad because if I want to exploit your browser and you have McAfee application control installed, you make my life very easy because I can just write my shellcode there and immediately start to execute it. Okay, here's the shellcode if you want to bypass the protections without data execution prevention. Just skip this one here. So as already told you, MP-CASP is the same as data execution prevention. Wasser is the same as address-based serialization, which is available since Windows Vista. And then you have these forced relocations, which is available since Windows 8.1, but also on Windows 7 with the updates. So if you keep your system up to date, you really don't need these memory protections there, because the protections from the operating systems are better and faster. I now come to user account control. All bypass techniques which I presented to you yet were working with normal user accounts, so you don't need administrative privileges for it. One technique on the next slides will require administrative privileges, but you don't really have to use this one, because you can, of course, bypass it another way, but it's just a simple one. And to use to make something with the administrative token, you have to bypass user account control first. So this one here was introduced with Windows Vista. I think every one of you knows these boxes here. This is called user account control. So if you log in as an administrator, you receive two tokens. So one token as a normal user and one token with full administrative privileges. And every time you want to use this full admin token, you have to click here on yes, I really want to do this as administrator. The problem is, if I'm attacking an administrator, I have to somehow bypass this stuff to make something as administrator. So there are many techniques to do this. I don't really have enough time to speak about all these techniques. Okay, yeah, fine, it's good. Yeah, there are many techniques that are very, very interesting. Basically, they just work by injecting a library into one of the processes. And the problem is you cannot inject the library because the library is not whitelisted, so that's why they are not working. But there are also some methods which are working, but I don't really have enough time to speak about all of them. So just know that there are techniques which work on McAfee application control or application whitelisting enabled systems to bypass user account control. As already mentioned, there are some processes which can be used to bypass the read and write protection. This is mainly the update processes, because update processes can be used to override any application. So write protection is completely bypassed. And we have the service itself, because the service can bypass read protection, because of course the service has to read all files. So let's start with the updates. I showed you this list some slides before. But just important to note here, here's the Java update process. And what you see here is, I have here a test.exe file, which is whitelisted, and I now try to copy test2.exe over test.exe. And you just see here, access is denied because of write protection. And you see in test.exe is just old. If I now configure my own update process, and the update process tries to copy something over test.exe, it just works. So you see test.exe was overwritten with some application which prints out new. So you see updaters can't bypass this protection here. So the idea is simple. What I can do is I can just start one update process, because then it runs with my own privileges, with the same privilege level, and then I can just open the process, allocate memory space there, write into the memory process, write my shellcode there, and then start execution of it. So this is exactly what I'm doing here. So here I just search for the Java update process, then I just inject my shellcode there, and the shellcode just overwrites this file. So here I have test.exe with old, and I just overwrite test.exe with new. So basically I can do this. Of course you cannot execute this exe file here, you have to implement everything in PowerShell or in shellcode or something like that. Then you can just overwrite any executable, which means you can run then any executable which you like. But you can also do it with the service, but this exactly requires administrative privileges because the service is running as system. But as soon as you are in the service, you can just remove the password file, which means you can interact with the sadmin program and just say sadmin disable, and the protections are all just disabled, and then you can do anything which you like. Or a little bit better, you can configure a trusted volume, which means there's just one directory and everything in this directory bypasses all protections. So don't have to reboot your system. I have here some kernel land related vulnerabilities. So you have here a driver, and basically you can interact with the kernel driver by sending different input-output control codes with parameters, and all of them here are vulnerable. So basically calling just one of them with malicious arguments ends up with a blue screen. And of course, it's very likely that you can use it to escalate your privileges. So for example, if you're a normal user, no administrative privileges, you can just send malicious input-output control codes with malicious arguments and exploit there are some vulnerabilities in the kernel to get access to the kernel, so you have then system access. I now come to the demonstration videos. Yeah, good time. So you see here, I'm logged in as administrator. I'm starting the command prompt with administrator. So this is exactly user account control. Then I'm saying here sadmin solidify. Okay, status first, which says everything is disabled. I now call solidify to create my whitelist. So it just enumerates all files. Let's just skip this. So after some time, in this case 11 minutes, it just says so many files are now whitelisted. So in this case 42, just because there was already a database and just 42 new applications. I now enable the protections and reboot my system. That's good. Wow. I'm now logging in as a normal user, so no administrator anymore. So that you see all techniques just work as normal user too. Here you just see that everything is working. I think I just skipped this. Here in the next video you see I have here a whitelisted application. You see you can run it, so it just prints out some window. If you just copy it, the copy of it would not be in the database, it would not be executable, not be whitelisted, which means execution is prevented. You can also remove it because it's not write protected, because it's not in the whitelist, but you cannot remove this one here because of write protection. So it first tries with normal privileges, now it says you don't have enough privileges. I'm now using it, trying it with administrative privileges, and it says you even don't have enough privileges, so you cannot remove it because of write protection. I'm now on my attacker system. Here I'm using Kali, which is free available, social engineering toolkit. In this case, I think you cannot read it very good. I'm saying social engineering attack. Then I'm saying PowerShell attack, and then alphanumeric shellcode injector, which means he should create for me the payload. Then I just say, give me a reverse shell which connects to myself back. Then I have here created it. Go a little bit forward. You see, this is the malicious payload. Now attack again on the victim system. Here I have the HDR file. If you open it up, so it looks like a normal executable, but if you open it up, you see here it's an HTML file with exactly calling my PowerShell script. Then I'm just saying start my reverse handler. I think here go to the next demonstration. You see here, if I start it, you really don't see anything. Of course, I can also start some other application as fake, and then I receive here a reverse shell. Can you read it, or is it too small? You see here, I have now a reverse shell. I'm in this process here, in PowerShell process. Okay. The next thing which I do is I'm uploading here putty. So I think it's maybe this way it's a little bit better to read. So I have now uploaded putty and now trying to execute this putty. So putty in this example is just my malware which I want to execute. So but because of application whitelisting, I cannot execute it. So you see here, so in this case, you see here, access is denied if I try to execute putty, but I also try to copy it over a whitelisted application, but this just doesn't work because of the write protection. You see here, access is denied. So the next step which I do is I just search for the Java update process, which is located here. So here, the last one is Java update process. That means I'm now injecting my own code into the Java update process. Forward. So now the Java update process, and since I'm an update process, I can just execute any application which I like, and I can also overwrite whitelisted ones. So in this case here, you see, okay, I'm just on the desktop, and I'm just now overwriting the whitelisted application with my payload, with my malware. You see it was working, and of course I can also execute it. So maybe here again, you see I successfully have overwritten it, and you can start putty. So if I go to my system, you just see it was started here, and of course the not whitelisted one you cannot start as normal process, but the whitelisted one can be started. So you can now start any executable which you like. And here's the last demonstration. This one just shows you if I have configured a password. You just see here, I require a password to issue some commands, like disable or enable or something like that. And my approach now is to remove the password file. So we have here the password file, it's here. A normal process cannot remove it or cannot read it, but if I inject my code into the process of the service, I can read it and I can override it. So you see here, access is denied as normal process. Let's just go here a little bit forward. I'm now injecting into the service, so migrating to process ID 644. You now can dump the password. It's a long hash, so this is good. But you can just remove it. So I'm now just have removed it, and if I then call here a shell, you can issue any command which you like without any password anymore. So you can now add trusted volumes or disable protections and so on. I now come to the conclusion. As you saw, the basic attacks are really prevented by application whitelisting. However, if you just modify the stuff a little bit, you can easily bypass all the protections. And even in some cases, you really lower the security of your operating system. For example, if you allocate, if your application whitelisting software allocates writable and executable sections in all processes, this is very bad because you would just remove the effectiveness of data execution prevention from the operating system. And if you have a software with kernel vulnerabilities in it, you allow privilege escalation, which also means you make your system weaker. I have here some hardening guidelines. Basically, you can just go to the advisory. There you can find more information how you can harden the system. But for example, you just have to remove all update processes or remove all the malicious, something like PowerShell and so on from a system from your whitelist. Here's the vendor response. So they said, really 2 vulnerabilities you reported are confirmed. So for example, the memory corruption. So if you allocate memory which is writable and executable, this is bad. However, they said this is very hard to exploit, so the risk is very low, so you just end up with a low score here. This is also the reason why they not provide a hotfix or a patch or something like that. They just said with the next release of McAfee application control, they someone will fix it. They also said, okay, the tip application with the buffer overflow in it is a vulnerability. However, they have some buffer overflow mitigation, so you cannot exploit it. So the risk is also very low. So it's 1.5 in this case. If you compare it with the one from InfoZip, they give it a 10 because, of course, you can exploit it. The other bypasses and vulnerabilities will not be fixed by them because they said it's just theoretical, there are no proof of concepts and so on. And of course, injecting into the update process requires administrative privileges, which is completely wrong. You can inject into an update process with normal user privileges because you can start the update process as normal user and you can inject into every process. So this is completely false, so not true. The same applies for the kernel vulnerabilities. They just said you need administrative privileges to send IOCTL codes. This is not true. You can send IOCTL codes as normal user, so you can exploit it as normal user. I already also tried it. You can crash their system with a blue screen as normal user. And of course, it's just said you need to run untrusted binaries and so on to make this, and this is prevented by our system, so we don't really have to fix this one here. So this was the complete timeline. Basically, they said they will fix somewhere. They said they will fix it at the end of the year with the new release. So here, yeah. So in March we sent them all the stuff. Then we received the vendor response that they confirmed 2 vulnerabilities of it. And we told them that they should really fix everything on it, but they just said they will fix these 2 vulnerabilities by end of Q3. Now, we have here at DeepSec, just yesterday I downloaded the newest version, which is 6.2, so there were 2 new versions, 6.1 and 6.1.4 and 6.2, and the status is that nothing of them was fixed. So even not the zip file or the writable and executable stuff, which is I'm now at the end, and if you have any questions, please just come to me or just come to me after the talk.
We have question for one quick question. Time for one quick question. No one?
Did you compare this memory memory protection with the Emmet tool from Microsoft?
Basically, Emmet has many more features, many more protections, like return on data programming protections and so on. And Emmet is doing it in a little bit better way. So for example, a little bit back here, what they are doing is, so McAfee application control tries to break every time someone tries to read the PE header here. So that's why they make it remove the readability of it. And emmet does the same, but it just makes it with hardware breakpoints. So there's just one field which needs to be read by malware, by shellcode. And what emmet is doing is they just place a hardware breakpoint. That means it's very fast. And what they are doing here is McAfee application controllers, they just make it here, remove readability of it. That means we get an exception, which is slow. Then you make the checks, and then you have to copy the instruction to a new memory location. This is exactly the memory creation, which is writable and executable. That's the reason why it's writable and executable. And then they can execute it, can break after it, and then copies everything back, and then start execution there, which is very, very slow. That's also the reason why your system becomes very slow if you install McAfee application control with the memory protections. So basically, emmet has more security features, and they're a little bit faster.
Well, thank you, René.
Thank you.